Hi sir, this is T. Kushi from ITA and my roll number is 37 and my topic for CN Tech Talk is Software Defined Networking Security. What is Software Defined Networking? Software Defined Networking is also called as SDN is received a great attention from the academic and industry recently and quickly became the new buzzword. This new networking paradigm is based on the idea of decoupling the network's control plane from the forwarding plane, which results in turning traditional networks' complicated routing devices into simple switches whose job is merely to follow the policy that is depicted by an intelligent and programmable, logically centralized controller. This is different from traditional networks shown in while routing devices are performing both forwarding and control functions in a distributed fashion using static protocols. SDN brings promising opportunities to network management in the terms of simplicity, programmability, and elasticity. These opportunities were quickly recognized by big industrial corporations, which started at an early stage funding research projects that aim at developing SDN. Today, the major networking vendors such as Cisco are releasing network infrastructure that supports SDN. Furthermore, the paradigm turned to be just what is needed for managing cloud and data centers. So here you can see an SDN network in the pictures. First, it is based on applications. It is link utilization view and delay view is present. Next it has network abstraction, and next it has network operating system, and then it is further connected into switches. So this is the SDN network. How does SDN work? Forwarding plane. This plane is made up of a simple switches that are interconnected to form the physical network. The role of these switches is to forward packets based on the control plane's routing policy. In order to achieve this role, each switch maintains a forwarding table whose entries are basically forwarding rules that get installed by the control plane. Each rule in the table is made up of three fields: pattern field, counter field, and action field. Next is control plane. This plane represents the network brain and is responsible for monitoring the network, making routing decisions, and programming the physical network how to behave. It is made up of three main layers: the network operating system layer, the network abstraction layer, and the application layer. As for the networking operating system, it is connected to each switch in the network using a duplex link. This layer collects state information from the network switches. So here you can see a traditional network. It has one part is control plane and the other part is forwarding plane, and they're internally connected. SDN security pros. The new structure of SDN paradigm brings great benefits to the networking scheme. The way the functionalities are abstracted in the SDN paradigm allows writing high-level software applications to manage the network without worrying how to configure the underlying physical network. This only one of numerous advantages that SDN brings. Our aim is to discuss those numerous general benefits, but rather to focus on those related to security. We identify three core characters that differentiate SDN networks from traditional ones. We discuss next each one of these characteristics, explaining why traditional networks lack these characters and how each one can be exploited to improve network security. SDN security pros. Global network view. Network-wide instruction detection, misuse detection, anomaly detection, detection of malicious switch behavior, network forensics, self-healing mechanism, increased control capacities, and etc. So let us see the SDN security pros over traditional networks. So let us see the differentiation. So coming to global network view, it is attributed to centralization, traffic, statics collection, and security use. It has network-wide instruction detection, detection of switches, malicious behavior, and network forensics. Coming to self-healing mechanism, it has conditional rules, traffic static collections, and it has reactive packet dropping, reactive packet redirection. Coming to increased control capabilities, it has flow-based forwarding scheme and access control. Summary of the new security issues that SDN networks are exposed to along with possible countermeasures. The first one is forwarding plane. So the malicious behavior in forwarding plane is switching DOS and packet encryption and tunnel bypassing. It is caused by the limited forwarding table storage capacity, and number of flows, limited switches buffering capacity, and invisible header fields. Possible remedy is proactive rule catching, rule aggregation, increasing switches buffering capacity, decreasing switch controller communication delay, and packet type classification based on traffic analysis. Next is coming to control plane. The malicious behavior is DDoS attack, DDoS attack, compromised controller attacks. So these attacks are caused due to centralization, limited forwarding table storage capacity, enormous number of flows, centralization. So to compensate it, you have to control the replication, dynamic master controller assignment, efficient controller placement, controller replication with diversity, efficient controller assignments. Next, forwarding control link. So here the malicious behavior is man in the middle attacks and replay attacks. So this is caused by communication messages sent in a clear way, lack of authentication, communication messages sent in a clear way, lack of time stamping. So this can be overcome by encryption, using of digital signatures, and timestamp inclusion in encrypted messages. So coming to the benefits of SDN, it is the first benefit is network segmentation. One of the tenets and intrinsic benefits of software-defined network security is easier network segmentation. Network segmentation involves creating subnetworks instead of large networks. Segmentation can help compartmentalize and organize your organization's network traffic. For instance, it may restrict your sales department's machines from communicating with your financial team's machines. This allows for more efficient bandwidth use by reducing the size of broadcast domains and reducing unnecessary traffic on the network. From a security perspective, it helps reduce an organization's attack surface and thus restricts the area of data security breaches. Therefore, when one machine or application is infected, segmentation blocks it from affecting separate devices and applications. The second benefit is that easier centralized remote management. So virtualized software-based network security is easier to manage from a single centralized dashboard. This means network and security administrators can access it and view it remotely. So if there is a breach, the relevant parties can be notified instantly. The COVID-19 pandemic saw companies migrating their workforces offset. So network security for remote and hybrid work environments must be more flexible. With software-defined environments, your organization's network security experts can track the security of all employees, no matter where they are. You can ensure that network security is consistent for on-site and off-site employees. The third benefit is that automation. Virtualizing network functions such as firewall facilities a greater potential for automation. A good example of this firewall architecture is current firewall architectures do not scale well, and this may interface with your business's agility. Virtual network firewalls allow you to benefit from the same features as physical firewalls, but they add more agility, flexibility, and scalability. Traditionally, to deploy and virtualize your network, you were required to script it manually. Today, companies can implement a turnkey solution to automate network firewall virtualization. Furthermore, because functions like these are virtualized, they can be updated automatically from their licensing to their policies. This makes it easier to keep up with the latest security trends. If you plan to migrate your databases or core network infrastructure, a virtualized infrastructure can offer smoother transition. So next benefit is scalability. A huge advantage of virtualized and software-defined network is scalability. It's far easier to scale virtualized processes and network components because they do not require the purchase of new hardware. You don't have to add more RAM and processing power to machines or buy new ones, especially if your virtual functions are running on cloud server. Most cloud vendors offer automated scaling. If your security requires more system resources, your vendor can provision new instances or services to it. And as your company continues to expand along with its network, its security requirements will also change. Security tools such as virtual firewalls can be deployed nearly at will, which allows for seamless growth in your operations. The fifth one is smaller physical footprint. Now that the physical network infrastructure does not handle your security, it leaves a smaller physical footprint. Software-defined security is hosted on virtual machines. Multiple instances can be run from a single server, which may be located on the cloud. Virtualized functions can be scaled up or down depending upon your company's requirements at any given time, which allows you to cut costs on infrastructure and service fees. Furthermore, these days, security is built into networking programs and other software as a part of development process. For software vendors, this means upskilling current employees through boot camps where they can learn how to code inherently secure software. For users, it means fewer resources are needed to secure their systems when software-defined security is built in. So I hope you understood all these things. Let us give a quick revision to all the topics which we have learned about it. So first we have learned about what is SDN. SDN is nothing but software defined networking. So it is completely based on security. So it is completely based on security. Here you can see SDN network. It has few layers. It has application layer, and in that you have link utilization view, delay view, and it has network abstraction layer, network operating system layer. Then it is connected to switches. So the upper part is called as control plane and the lower part is called as forwarding plane. You can see in the picture. Coming to the working of SDN, so it has mainly two things, forwarding plane and control plane. So coming to forwarding plane, this plane is made up of simple switches that are interconnected to form the physical network. So it is very simple. It has simple switches in which the switches are connected physically, interconnected physically. Whereas in control plane, these planes represents the network brain and is responsible for monitoring the network. So this is logical, that is physical. Basically, this is logical layer and that is physical layer. And this layer collects state information from the network switches. You can see in the picture. So SDN mainly consists of two parts, control plane and the forwarding plane. So these two parts are interconnected and the applications are maintained. Security is given. So what are the advantages of SDN security? So why you have to take this SDN security? Why you have to give it more priority? So global networking view. So it has a wide intrusion detection, misuse detection, anomaly detection. It also has a capability of detecting malicious switch behavior, network forensics, self-healing mechanisms, and increased control capabilities. So here you can see in the table what are SDN characteristics. It has global network view, it has self-healing mechanism, and it has increased control capabilities also. And what are the usage of this security? So it is used for wide intrusion detection, for malicious behavior, for network forensics, for reactive packet dropping, for reactive packet redirection, and for access control. So, and summary of this table. So, as you all know, in SDN, you have two main parts, forwarding plane and control plane. So, mainly malicious behaviors are like switching DOS, packet encryption, and tunnel bypassing, DOS attack, man-in-the-middle attacks, and replay attacks. So, mainly these are caused by limited forwarding table storage capacity, centralization, and the communication of messages is not clear, lack of authentication. So these are some of the main reasons. So to overcome these things, you have to proactive rule catching is to be done, and you have to control replications. You have to control encryption. Timestamp inclusion is encrypted messages. You have to use digital signatures to provide more security. These are the steps that have to be taken. So benefits of SDN is that the first one is network segmentation. So generally, network segmentation makes it easier. Network, it involves creating sub networks inside a large network, and it makes it easier. And coming to the next one is easier centralized remote management. So here you can manage the network security from wherever. If you're, for example, in COVID-19, everybody, each and every employee was working from their homes. So even though they are not in the office, if they are on onset or offset, you can maintain the security. So it is easy to maintain the security. It is not dependent on particular place or something. Wherever it is, from one part of the world to another part of the world, you can maintain the security. The third benefit of SDN is that it is automation. And the fourth is that scalability. So a huge advantage of the virtualized and software defined network is scalability. It is far easier to scale virtualized processes and network components because they do not require purchase of new hardware, and you don't need to add a new RAM, also new amount of RAM. So mostly cloud vendors make a very good advantage of this SDN, that is security defined networking. And the next one is smaller physical footprint. So now that the physical networking infrastructure does not handle your security, it leaves a smaller physical footprint. So these are some of the benefits of SDN. So coming to the conclusion, SDN security will help bring about other security trends such as zero trust network access and increased cloud adoption. The benefits of software-defined security are evident, and there is no reason to delay in implementing it in your organizations. So I hope you understood about SDN, its benefits, it's working and what are its advantages and all. So I hope after knowing this, everybody will be interested in including SDN in your organizations. Thank you so much.